Why, hello, lovely humans. Jen Foxbot here for another edition of Math Mondays. Da 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 da. Yeah. All right. In this episode, we are going to tackle center of mass. Yes. My nefarious reason for wanting to teach you this is because I want to show you how to calculate the stability of an object, which is a problem that I did a few years back for a parkour gym. So basically, what I was doing was finding different objects' center of mass and then calculating what would happen based on the weight and shape of the object, given a person jumping on the object at various different angles. And it was super useful. And it was a really cool real world application for some of the engineering work that I did when I was in school. And also, center of mass is just a really handy concept. It pops up all the time in physics and engineering. And it's not the easiest thing to understand or calculate. Well, I might argue that it's actually easier to understand than it is to calculate. So what is center of mass? Well, the center of mass of an object is the point at which you can kind of think about it like a weighted average, where you're kind of adding up all of the tiny little pieces of the object, and then you're finding the shape of the object, and the shape of the object is kind of like the weight, the weighted part of the weighted average. So what does that actually mean in practice? It's kind of hard to put words to, and a lot easier to put math to it. So let's take a simple example. Let's say that you, I have a nephew who's a little adorable baby, and I wanted to make a seesaw in my backyard. But I weigh a lot more than my nephew, and so if I want to make sure that I don't launch him into the neighbor's yard, I want to think about where I'm putting the fulcrum of the seesaw, because my nephew weighs a lot less and is a lot smaller than I am. So I want to make sure that we're both safe. And also, if I don't put it in the right spot, I'm just going to be sitting on the ground and nothing's going to happen. So let's draw a simple picture of that. So I grab a piece of wood, and my little bit of a nephew is on one side and I am on the other side. And like a standard physics and engineering problem, I'm going to simplify this by representing me with a larger circle and my nephew with a smaller circle. Maybe I'll put a birthday hat on my nephew, because why not? And maybe I'll give myself some curly hair so then you know that it's me. Okay. Cool. So we're going to say that this is M1 and this is M2, and M2 is much, much larger than M1. Let's also say, to start, we'll just represent the fulcrum by the center point, and the question really is, where do we put this so that both my nephew and I can use the seesaw in a way that is fun and safe? So, okay, we need to do a weighted average, and that basically means, so we're trying to find the average of these two masses, and the weighted part is the distance of the two objects. And so to figure out the distance, we have to set up a coordinate system. And since we are in charge of this problem, we get to pick where our coordinate system is. So I'm going to pick it a little bit to the left of the seesaw. And so then I'll say that the distance of my nephew from our origin point, where x equals 0, is just going to be x1. The distance that I am is x2. And then the distance to the center of mass we can represent with xcm for center of mass. Ha! Okay, so now we do the weighted average. So the center of the location, or the distance of the center of mass from our origin point, is going to be equal to the weighted average of the masses. And to do that, we add up the masses and multiply each individual mass by the distance from the origin. So that would just be m1 plus, m1 times x1 plus m2 times x2. If we had multiple objects on our seesaw, we could just keep adding them, and then we divide by the total mass of our entire system. So this is what I mean by a weighted average. So we are finding the location of the center of mass, but to do that, we have to find the weighted average of the masses of our system, and that is dependent on, the masses of the two objects, as well as the distance that they are from our origin. In doing this calculation, now you can probably see why I didn't set the origin to be the center of mass at the seesaw, or the very edge of the seesaw. You can actually pick whatever origin you want. You can put it in the center here, and then in that case, my little nephew or whatever object that you have would be a negative distance, but that's okay. You're still going to get the center of mass in reference to your origin point. There you go. So that is how you calculate the center of mass of a discrete system, or basically a system with multiple objects. But how do you calculate the center of mass of a continuous object? Or basically, if I had a really long bar, let's say I wanted to find the center of mass of this piece of wood, because that would actually affect where I want to put my fulcrum point. All of a sudden it's getting more complicated, but that's okay, because we can totally do that. And in engineering especially, it's really, really important for us to check our intuition and say, our intuition would probably say, well, the center of mass of this plank of wood is just the halfway point. But how do we know that? We got to calculate it. All right, so I'm going to do that in part 2. So check out part 2 to learn how to calculate the mass of a continuous object. We'll see you there.